Good morning, everyone. My name is Roberto Vogadro from University of Milano Bicocca, and today I will be talking about a framework for quality assessment of semantic annotation of tabular data. Look at this table. Suppose you have developed a semantic table interpretation approach that finds that the first column is about plants. Is it correct? Maybe it is easy enough for you to spot that there is an error. But what if you have no familiarity with the table domain, or you have 1,000 tables annotation to evaluate? StillTool is the answer. As a tool for the quality assessment of table annotations, it can easily detect where you are doing well and where you are failing, helping you to identify common error patterns. Track your progress over time and help you improve your approach. By the way, if you are wondering, the first column is about Pokemon. There are a lot of tables on the web which contain valuable information. For instance, 2.million tables are contained in the Common Crawl repository, and more than 3.2 tables contained in Wikipedia articles. Unfortunately, those information cannot be queried and cannot be easily understood due to the lack of the contextual information. Several techniques have been proposed to semantically rewrite tabular data and make them human and machine readable. In particular, we consider the semantic table interpretation approach that, given a relation table T, a knowledge graph comprising a type hierarchy with subtype relations and entities that are instances of types. The tasks to annotate a table T using a knowledge graph are cell entity annotation to associate each cell in a table with an entity, column property annotation to associate each pair of columns with a binary relation, and finally, column type annotation to associate each column of the table with at least a type. In this case, we can identify two groups: column type annotation for entity and column type annotation for literal. To produce the annotation of the tabular data through the STI, we need to consider a well-formed and normalized relation table as the one taken from T2, the gold standard, and a knowledge graph which describes real-world entities in the domain of the interest. The output returned will be the semantically annotated table on the right-hand side. Modeling and constructing semantically annotated datasets poses different quality issues due to the automatic procedures which are often error-prone, the autonomous information providers who are not aware of the final usage of the dataset, and finally, the schema-last approach, which allows to first publish the data and optionally creates the schema. There already exist some approaches which are mainly focused on the quality assessment of the datasets. Some mainly focused on conceptual and theoretical frameworks, other more on tools and methodologies for the practical quality assessment of the datasets. Our aim is to assess quality during the annotation steps of STI and not at the end of the achieved result. Inspired by the approaches on the quality assessment of mapping languages, we propose an open source framework which will analyze the root causes of the semantic annotation process. We extended the previous systems tool, StillTool, which was mainly used to compare the annotation with respect to a gold standard, by adding several quality metrics. We provide quality metrics and their relation with the annotation step, which should help to detect possible quality issue of the annotation process. As we may seek from the table in the rows, we propose the 9 quality metrics, and in the columns we have the annotation steps. The quality metrics proposed here need a gold standard which may present some advantages. For example, highly reliable result and disadvantage, for example, costly to produce. However, our Steel Tool 2 is designed to support both situations, if the gold standard is present or not. We propose a methodology composed of 3 phases, where each phase corresponds to 3 different levels of granularity that are a single annotation step in isolation, the combination of 2 annotation steps at distance level, and finally the combination of 2 annotation steps at schema level. For each step, there is a set of metrics applied for capturing the quality issues. Metric can be further aggregated to produce a single quality score. To each metric, we may provide a weight according to its importance with respect to the annotation steps. In the first phase, we focus on assessing the quality in terms of completeness and consistency of the single annotation steps. In the second phase, we focus on assessing the quality in terms of interlinking completeness and accuracy of the combined annotation task of SIA and CPI. For example, consider the triple returned where the property is not correct. Thus, this is considered a non-accurate triple. In the third phase, we focus on assessing the quality in terms of interlinking completeness and accuracy of the combined annotation task of CTA and CPA. For example, consider the triple returned where the subject type is not correct with respect to the gold standard, since the subject type should be place and mountain, and natural place are not correct since they are both ancestors. The tool is available through a Git repository and is encapsulated in a Docker container. As shown from the interface, there are information on metrics and statistics on the most common errors. Steel Tool 2 is evaluated based on the datasets used in SEMTab 2020 challenge, where the real-world dataset involved in the challenge represent multiple kinds of dirty data. We may assess our approach only against one gold standard at a time. It means that new gold standards can be uploaded separately, and the same table can be evaluated on different gold standards separately. As shown from the table on the right-hand side, completeness is higher than accuracy, which is an indication that while the retrieved entities, properties, and types are almost the same as indicated by the gold standard, the correctly retrieved entities, properties, and types are less, as shown from the table on the left-hand side. The entity candidate coverage metric is obtained by Mantis table because the data from the other approaches were not available. As expected, the result obtained on tau tables is lower than the standard tables due to its complexity. This is also an indication that the next steps of the annotation process will not get a further improvement. Therefore, this metric will serve as an upper limit and will influence our decisions, thus saving time and resources on the computation of the next steps. This result shows how many times we get the perfect annotation. In this case, the perfect annotation
is not found, then the approach will propose the first ancestor or descendant. Otherwise, this type is classified as an error. Most of the approaches will get not the most specific or generic, but the wrong types, which can be related to the fact that the wrong annotation is identified or because it was not found. The proposed quality assessment framework may be used in many use cases. This includes the following three scenarios. The first scenario is comparison and evaluation of semantic table interpretation approaches. The second scenario is integration and quality assessment of product data. And finally, the third scenario is natural language generation of RDF triples. In summary, we may say that we provided the contribution listed in this slide. Thanks for your attention.